Hi guys, greetings from Bulgaria, I am Anton, and in today's video we're going to talk how to use Apache HTTP Client to get HTTP response status codes, and we're going to integrate them in our Selenium web tests. In the video we are going to discuss what are the different types of HTTP status codes, why they are important, and how they are related to your automated tests. Then we're going to see some code examples, how to integrate Apache, the newest version of the HTTP client, in our automated tests with Selenium, and then we'll end up with a little bit more complex code, and we're going to build full-fledged broken links checker. If you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when there are new video published on the LambdaTest channel, and you get notified. Many new videos are published each week that are quite informative, and also check the LambdaTest blog, where it's a great resource to learn to write proper automated tests. Without further ado, let's begin with discussing a little bit of theory about the HTTP status codes. As our automated tests grow in complexity, they often go beyond simply interacting with the UI. That's why I prefer to use the term like end-to-end tests, system tests to describe them. And these tests may call web APIs to set up and verify information in other subsystems or microservices. And as you know, we're discussing this a lot in the videos, but while Selenium WebDriver is a powerful library for browser automation, it is not a dedicated test automation library. Therefore, it lacks some of the specific testing functionalities that we need to test our application efficiently. To overcome this, we use it together with native unit testing frameworks like JUnit or TestNG. If you're not familiar with them, check the LambdaTest channel. There are dedicated video series about both of them. Similarly, when working with web requests, we may need to perform them outside of the browser and inspect what's happening behind the scenes. HTTP status codes come in handy for verifying specific and complex automated scenarios. And to do this in Java, as you'll see in a minute, we can use the Apache HTTP Client library. Just let me give you a simple example. For example, by the way, this is a great article about how to get responses and status codes using Apache HTTP Client that you can read on the LambdaTest blog. Also, for the demos, we're going to work again using the LambdaTest Playground. This is an excellent resource and demo website that basically you can test your knowledge about WebDriver. When we open the network tab, as you know, in developer tools, if we refresh the different HTTP requests are captured, and as you can see, each request has a request URL and a status code. Basically, when a client sends a request to the server sends a response back to the client. In our case, the client right now is the browser. Later in Java, we'll use the HTTP client, but basically the server sends a response back to the client, and this response contains a status code, which indicates whether the request was successful or not. And HTTP status codes, if we return to the information here, HTTP status codes are 3-digit numbers that are included in the response message header. The first digit of the status codes defines the class of response. There are 5 different classes of HTTP status codes, each with its own specific meaning. For example, the first one in black here, 100, this means informational. These status codes indicate that the server has received the request and it's continuing to process it. The client should wait for a final response. The ones that are here in green, 200 to XX successful, these status codes indicate that basically a response that indicate that the request was successful and that the server was able to fulfill the requests. And of course, the most common of this is 200 OK, which indicates that the request was successful. And the one here in the red, 300, this means redirection. These status codes indicate that the client must take additional action to complete the requests. This may involve redirection to the client to a different URL. Then here in blue, 400 or client error. These status codes indicate that there was an error with the requests that the client sent to the server. And this can happen if the client sent an invalid request. The requested resource does not exist, or if the client does not have permission to access the resource. And the last one here in purple or pink, 500 server error. These status codes indicate that there was an error with the server when processing the requests. And this can happen if the server encountered an error while processing the requests, or if there are a range of 200 to 299. Or while processing the request, or if the server is temporarily unavailable. Each class of status codes, this was what I wanted to tell you, has its own range of numbers. For example, all 200 status codes have a number in the range of 200 299. Similarly, all 400 status codes have a number in the range of 400 499. And maybe you are wondering, but understanding HTTP response status codes is important for anyone working with web application or APIs. By understanding these codes, you as test automation engineers, we can more easily troubleshoot issues in ensuring that our applications are functioning as expected. And in the next part of this course, we'll look at some specific examples of HTTP response status codes, including common 200 or 400 codes and what they mean. And during the code examples, we'll look at how to use the Apache HTTP Client to send HTTP requests and get response status codes in Java. As always, you can download the let me write this for you. We can basically, you can download the full source code from the GitHub repo, and from the GitHub repo that you can find in the links below in the description, and also you will find many other useful resources. So first, here this is like a regular normal JUnit Selenium Java project. I used POM and basically Maven dependencies to create the project. And if you're not familiar with JUnit, I suggest you to check my videos on the LambdaTest channel about it. Also, there are many detailed videos about how to use Selenium with JUnit together and how to use it with Maven. So I will not focus on this particular part. I use the latest current version of Java, and I installed all of the JUnit required dependencies here in the POM XML, which is basically the main Maven file for mentioning the dependencies. And when you open the Maven repository website, you can search for these particular dependencies. So we have the JUnit ones, we have the Selenium ones, and the WebDriver Manager, which is responsible for downloading the proper driver. And the one that it's valuable for this particular tutorial is this HTTP Client 5. This is the latest version, current version of the HTTP Apache Client. So you need to be sure to add these two dependencies. Basically, compile means that it will be available when we work with source files here, and when you mention the scope tests, these dependencies will be available in our tests. So here, this is again a regular Selenium test class. We have here first an instance to the Chrome WebDriver. before all of the tests, we're using the WebDriver manager to download the proper driver version, and before each of the tests, we're going to download the Chrome driver. That's all. So first, let's build a simple request using the HTTP client. What we need first to do, for two of the demos, I will just type the code so that you get used to what I'm doing, and then I'm going to explain the more sophisticated examples. So let's make a simple head request. The head request, usually we use it to check for broken links, because the head request doesn't require a body. We just check the status code. So we need an instance first of the HTTP client. So we'll have HTTP client, then we'll name this client, then we're going to use HTTP client, which has a static method called new HTTP client. This will create an instance for us for, let me make it bigger, a little bit bigger for you. We will use this client to make the requests. Then we need to define what our request will be. So we need to create HTTP requests, then let's create the requests, and again using the HTTP request class, it provides a builder method, static builder. If you are familiar with Actions API that we use in Selenium for drag and drop and other sophisticated, more complex actions, basically the Actions API uses the builder design pattern, which allow us to use chaining methods, or this is called Fluent API. Basically, instead of defining on each separate row methods and then using defining them every time, we just continue to mention the different methods, and in the end, for example, for Action API, we need to call perform, but here, in order to build the HTTP request, we need to end up with build method. Inside the URI method, we need to specify basically the URL where we're going to perform the request. So it requires URI class, so we need to define new URI, and then we need to specify the link to the resource. In our case, this will be the LambdaTest playground. Then on a new line with dot, we need to specify the method. What is it complaining about? Yeah. Oops. You don't need to call here build. Then we need to call method. Inside the method, we need to mention that this is a head request. And in our case, since we don't need basically the body or the actual HTML of the website, of the basically the URL that we are going to make the requests, we need to call body publisher no body, HTTP requests body publishers no body, and this means that when you make the request, there will be no body included, and it will be a little bit fast. And then in the end, as I said, we need to call the build method, and we already have the initialized requests, right? Then we need to use there are two ways how we can make the requests. In the first example, I will use command send to make the request and receive a response. Since we don't have a body, our response in this case, as you can see, it's a generic class, and since we don't have a response right now, here the response will be of type void, like our methods here that are void, right? So I will name this variable response, and then we're going to use client and send. Here first I'm going to supply the request, and then I need to mention HTTP response body handlers discarding. This means that we are going to discard parsing the body, right? And that's it. Now we have the response, and our since the tutorial is about how to receive status codes, we need to get the status code. So in order to do that, from the response there is a method called status code, and we are ready and we have the status code. So let's sum up what we did. This method uses the HTTP Client API to create a header request to the specified URL and gets the response status code. We use this client variable here, and we basically use the new HTTP method to create a new instance of the HTTP client and then create a HTTP request object using the HTTP request.newBuilder method. The method is set to head, and the URI is set to the URL we want to send the request to. The request body is empty, so we set it to bodyPublisher.noBody. Then we use the send method to the HTTP client object to send the request and get the response. And the response object returned is of type HTTP response void, since there is no response body. And finally, we get the response status code and print it to the console. So this is a simple way how we can check for broken links and get the status code. Sometimes you may need to further configure other additional stuff of the requests, and this code here, this is a test method that checks how to configure the timeouts for HTTP client using the Apache HTTP components library. It sets the connect timeout, connection request timeout, and the response timeout to 30 seconds using this request config custom method. Then it creates an HTTP client instance using the HTTP client builder.create here, and we need to call this set default request config to set the configuration for the requests. Then it creates finally it sends an HTTP head requests to the URL of the Selenium playground using the execute method. This is the second way how we can perform requests. We are not calling send but execute, because we have pre-configured configurations. And then we print the response status code, and if the request takes longer than 30 seconds to connect, basically there will be exception. By the way, if you check the blog about HTTP status codes on the LambdaTest channel, you will notice that the author used another approach using HTTP connection, which is the older approach for older Java versions. So if your project is using older versions of Java, Java 8 or something similar, then probably you have to check how to do that in the blog post. However, here I use the newest suggested approach using the HTTP clients, since it's more flexible, simple, and allows you to do more complex stuff. Also keep in mind that when you're building complex Selenium tests, there are special libraries for testing web APIs like REST assured. And of course, when you are dealing with web APIs and you need to, for example, create test data or verify data in the microservices or web APIs, it's suggested to use REST assured. However, for such simple tasks as checking the status codes, it suggests to use the HTTP client. Since basically the REST assured, if you check since it's open source tool, if you check basically its engine, you will notice that it uses the same thing, the HTTP client. So let's use the basically let's create a test. Let's create a test to check that all of the links here, that there are no broken links on this particular URL. Let's see how we can do that using this HTTP head approaches. So first we need to define values, for example, valid links set to 0, and then broken links equal to 0. Then we need to navigate to the LambdaTest playground, and we need to get all of the links, right? So we will return a list of web elements, and let's call this link elements. In these link elements, in order to get them, we can use the find elements method, and we can get them by tag name. As you know, all of the links are using A, which stands for anchor, and basically if we inspect here, as you can see here, the anchor, the actual link is contained in this href attribute and its value. So we need to obtain this attribute href to get the actual link. And then we're going to use the HTTP client to perform a head request to this particular link to see whether the link returns the proper status code, and this is how we will deduct whether the link is okay or it's broken. So this will return the elements. We can name these links or link elements as you prefer. So we can for each all of these elements like this. And as I said, we need to obtain the actual URL. So in order to get that, we need to call link, then get attribute, and then here we're going to mention href. This will return the actual value of this attribute. Then we need to initialize the HTTP client. By the way, or maybe it's even better to move it above here, because we don't want it every time when there is a new link to create a new HTTP client. This is not needed. We can reuse the instance. Also, if you don't want here to iterate the actual elements, we can extract exactly the particular links using the stream API. Let me show you how to do that. We'll continue to use this approach, but I want to show you a little bit more concise code. So let's name that links1. We can get this particular code as well, but now we'll call stream, then map. Basically we will extract just the information that we need from the element. In this case, we have a link, and we are going to use lambda expression, which will basically iterate like this all of the links, and basically the map method will contain only this here. So we need to mention L, which is the anchor, get attributes, in this case href, and then we need to move this particular map. We need at the end to call collectors to list, which will transfer this map stream. It will move it to a list. Basically this will be this will contain a list of all of the URLs, and then we can for each just them instead of doing that every time in the for each here. But for now, I just wanted to show you this little trick. Since we have already the HTTP client, we need to build the actual request. So we need to type request, and then if you remember, we need to call HTTP request new builder. Then on the new line, we'll mention the URI, which in our case, it will be the URL above. And then we need to specify the method. In our case, this will be head. And if you remember here, the HTTP request has body publishers, where we need to say no body. That's it. And then we need to use, maybe here we'll need to wrap it inside a try catch, because many times if, for example, there is a broken link and if the URL is not correct, then probably there will be a problem. So let's type that var response, and then client send, I made a typo here, requests, and then HTTP response body handlers discarding. And what else? So here, this will be our code. Also, it suggests that probably we will need a two catch clauses like this. What is it complaining about? Yeah, maybe we need to HTTP request new builder URI create. So we have here the response, and inside the response we need to check after that the particular status code was, what was it, in order to increase. As you can see here, if there is an exception, we're increasing the count of the broken links. In case there is a problem, actually we need to do the if here where we have the response. So here we're going to say status code equal to 200, then we're going to print that there is a successful connection, else we're going to increase the broken links here. And at the end we can print how many links there are that are okay or not from the broken links and valid links, like here. So let's see something else. If you open there is another article on the LambdaTest channel for how to find broken links using Selenium WebDriver, which is a great resource. You will find that here again we use the older HTTP connection library, which is fine. I mean, back then many people are still using older Java versions, but I wanted to show you here that actually the author uses basically added additional checks. I just want to explain these checks. All the rest of the code is the same. What are the additional checks? First, if the URL is null or empty, we just continue the for each loop, and we are ignoring these URLs and we are not counting them as unsuccessful. Then sometimes on some of the pages, as you know, for example, connect send a request to the support or something else, or info emails, there are some URLs that start with mail to, or they contain phone numbers to again contact the company. In these cases, again, we need to ignore these URLs because they are not proper links to other pages, but you know, emails or phone numbers. And in case there, you know, the link is a LinkedIn page, for the LinkedIn, many often for security purposes and others, when you make HTTP requests, these head requests are returning status code 999, and this means basically that you cannot crawl it, but it's still there and it's valid. You can read in more information and detailed explanation in this particular blog post. And lastly, we will finish with a little bit more complex scenario, because until now all of these examples are checking just a simple web page for broken links. But imagine that you want to check the whole website for broken links. Instead of, you know, checking all of hrefs and using WebDriver, whatever, actually we can extract them from the sitemap. What is the sitemap? Each website is suggested to have one. Basically, this is a map of all of the URLs present on the website. It's often used by search engine crawlers, bots, for checking your website, and even if you don't have such a sitemap, basically you will have a penalty, and most probably your website will be put not at the first places in for example Google, Bing, or whatever, because basically the bot will need to use more resources to do the same approach for checking all of the links manually and then growing them, etc. But it's much easier than just get all of the URLs and check them later. So this is exactly what I did, but as you can see, there are many of them, and we want a faster approach. This is why I did two things. First, I extracted all of the URLs from this XML in a list. Then we iterated them, but in order to make faster the HTTP requests, we basically used a Java code for making and executing the code in parallel in 10 different process threads. So let me show you how I did that. Basically here I navigate through the playground, not this, here. So first we initialize the HTTP client, then we initialize the request to the sitemap, then we perform, but this time with the body handlers. As you can see here, we extract basically the body, and this is why it's not, the HTTP response is of type not void but string. And then we use this code here. It's not so important, but basically we're parsing the XML, and as you can see, we are iterating through different nodes, and we are extracting all the URLs inside this list of URLs here. And then the difference between this particular test and the other is that this time we use the executor service, which is a special Java class for creating 10 different threads here at the below. And also note that here, instead of using simple integers for holding the valid links count and broken links count, we use atomic integer, which is used to update the count of the valid and broken links in a thread safe manner, as the links are being checked in parallel, and deadlocks may occur. This is why here, instead of using ++ operator, we need to call get and increment. And also here, just to see how this older HTTP URL connection API works, for older Java versions I used this API instead of the HTTP client version 5. So we need to cast this. Basically, for the URL, we open the connection, we cast to HTTP URL connection, we set request to head, and get the response status code. And we can check whether it was okay or not. At the end, don't forget that we need to basically use the shutdown and await termination methods to gracefully terminate the executor service after all URLs have been checked. That's all. And then we print them. Thank you for watching. I hope that the video was useful to you. If you have any questions, put them in the comments below. I will be happy to hear your thoughts about the content, and if you have any specific issues or wishes for new videos that you want us to record. Also, don't forget to check the LambdaTest blog and the many awesome resources there to learn better how to write automated tests. And don't forget to get your LambdaTest certification about JUnit, Selenium, and many other technologies. Thank you for watching, and see you in the next videos.